Today our group will present about shared memory. Processes. Inter-processes communication, which we will use IPC for short, is a set of processes executing at the same time within an operating system. The two types of IPCs are independent and cooperating. A process is considered to be independent if it cannot affect or be affected by other processes executing in the system. However, cooperating is the opposite, where another process can affect it or it can affect another process. When two processes are to be considered to be cooperating, they require an IBC mechanism that will allow them to trade information and data. One of these mechanisms is message passing, which is where two processes send data back and forth, and the other mechanism is shared memory. It's when two or more cooperating processes agree to share a region of memory. The processes can then exchange information by reading and writing data to the shaded region. Shared memory has some advantages over message passing. For example, shared memory have processes executing concurrently, needed only one system calls, and it can share huge amount of data, while message passing is said to have a better performance with multiple processing cores. We will be focusing on the shared memory since we prefer the underdog. Shared memory is superior in terms of speed since message passing requires a lot of system calls, where shared memory only needs to use system calls to create shared memory location. After the memory region is created, it is up to the process to manage this shared area. One issue we unfortunately have to discuss is the consumer-producer issue, where regulation of reading and writing to the shared memory location has to be performed. To solve this issue, a buffer can be implemented, which can be unbounded or bounded. In the case of unbounded buffer, there is no limit to the size of buffer, and the consumer may have to wait for the new items, but the producer can produce at any time. The bounded buffer has a fixed size, and the consumer has to wait for the data if the buffer is empty, and the producer must wait if the buffer is full. Furthermore, in virtual memory, copy on write works by allowing the parents and child process to share the same page. However, anytime a parent or child modify a page, a copy of that page is created. Now let's watch our illustration about shared memories.
Alright, let's get started on this document that's due in 2 months since we do not like procrastination.
Yeah, okay, let me create a Word document and I will do the introduction. Hold on.
Alright, that sounds good. So, make a Microsoft Word file, then fill out the header in MLA format, and then you can start the first portion of the paper and then send me what you have through Messenger so I can add the second part.
Okay, I created a Word document and completed the first part of the document. Now let me send it to you as you requested. Send.
Alright. This process seems a little bit tedious, doesn't it? I would hope that there's another way to work on a document collaboratively other than continuously sending each other the updated file back and forth.
I agree. There has to be a faster way to do this.
I overheard you guys. You were talking about some software where you can exchange information, reading and writing, on the document.
Yeah.
So, Alex, what you want to do is that you want to open up Google Docs.
Alright.
Okay. So once you do that, you want to create a document. Okay. And now you want to give permissions to pre-tier.
Alright, let me do that real quick. Okay, that's all done.
All right. Now, Pre, do you have access to that document?
Okay, let me see. I just checked. I do have access, and now I can modify and access the document.
Yeah. I can actually do the same. I can modify the document as well.
All right, perfect. So just make sure that whenever you two are modifying on the same part of the document, you just don't override the same information.
Oh,
Okay.
Cool.
We'll be able to do that.
Yeah.
I think that was good.